All right, let's take a look at our lesson on double angles and half angle formulas. Yay, more formulas, right? You're probably like, oh my goodness gracious. Okay, so let's kind of just remind ourselves, so far we picked up several formulas from chapter 6. We did like the reciprocal formulas, properties, quotient, Pythagorean identities, remember all of those. Of course, we continue to use those. These are some additional ones that are going to be helpful for us. These are called the double angle and half angle formulas. So the first question I normally get is, what in the world does it mean by double angle? What is that? So I want to address that concept first. What does it mean by a double angle? What that means is that this 2 is the double part. That's the double part, and the x represents the angle. I mean, x is the angle, and 2 is double. It's the double angle. So when we have a double angle, it may be to our advantage to turn it into single angles. And that's what this formula does, is it takes a double angle and it turns it into single angles. See how this x is just a single angle. It's not a double angle, and so is that one. Those are single angles. So that's really the main reason for this formula, so that we are able to get out of being a double angle and turn it into single angles. So there are two main ones that we want to, the ones we use most frequently are the double angle for sine and cosine. And if you recall, last time we talked about the personalities of sine and cosine. Remember that? How sine is so nice and sine shares and cosine isn't that nice? Well, that kind of carries over to these formulas as well. Take a look at the double angle formula for sine. So sine's double angle formula uses a 2. Well, that's nice because it's a double angle. Yay, that helps us. And look how sharing it is. It's just sine times cosine. Okay, so sine is keeping up his personality, just a very nice, sharing, happy to, collaborate with cosine. But look at cosine on the other hand. Cosine's double angle. Yeah, there's no 2. There's no nice big 2 here. And plus, guess who gets to go first on cosine's double angle formula? Well, cosine does, right? That's who gets to go first for cosine is cosine, because that's the way cosine is. So cosine goes first, and they're squaring it. Cosine squared minus sine squared. Why? Well, because it's cosine, right? Cosine squared minus sine squared. So these two formulas are the ones that I memorize. This set of formulas right down here, I really don't memorize because I can create them using Pythagorean identity. I can create them from this original cosine formula. And I just want to kind of walk you through how you could do that if you don't want to memorize the additional formulas for cosine. So we know that sine squared plus cosine squared is 1. We know that. And in this first rendition, so this is rendition number 1, if you will. In this first rendition of the formula, there's no cosines in there. So what did they do? Well, they solved this for cosine. So they said cosine squared is 1 minus sine squared. And then they took the cosine squared out and turned it into 1 minus sine squared. So I'm rewriting this one to be 1 minus sine squared minus sine squared, which generates this first additional formula, which is 1 minus 2 sine squared. So that just takes a couple seconds for me to do, and it really is helpful because I don't really want to memorize extra formulas if I don't have to. So let's investigate how this second, the second formula, our second additional or alternative formula is created. In there's no signs, so they got rid of signs. So what do? They took the Pythagorean identity, they solved for sine squared, Sine squared is 1 minus cosine squared. And then what they do, they took out the sine squared and put in 1 minus cosine squared. So I'm recopying this formula. So that's cosine squared minus, and then I'm going to insert 1 minus cosine squared in the place. And then if you'll notice, that will generate this second rendition of 2 cosine squared minus 1. So I like to walk through that with you just to see how versatile the formulas can be and how you can save yourself some memory work if you simply just remember sine squared plus cosine squared is 1 and use it to substitute. Okay, are we okay so far? Okay. So the formula for tangent, and I just want to pause here for a second. I know that I write fast and talk fast, so I just want to pause, make sure we're all good. So the formula for tangent 2x, you could get away, with simply doing the sine 2x formula over the cosine 2x formula, which would be 2 sine cosine over cosine squared minus sine squared. That would give you the same result that you're looking for with the tangent formula. I'm going to use the tangent formula just so we can see it practice being used. But what I'm saying is this is not a formula that you have to memorize, because you can get around it by using the double angle formula for sine over the double angle formula for cosine. And that will still get you what you want. Okay, so that is certainly possible. The double angle formula for tangent starts out with the numerator is just 2 tangent. That's kind of nice. It's got a 2 in it. I kind of like that. And in the denominator, it's 1 minus tangent squared. So that's that formula. Okay. Any questions? So do we understand what it means by being a double angle formula? We know what that means. Are we okay with the formulas themselves? Do we have any questions over that? Okay. All right, so after spending some time on double angle formulas, let's go over to our half angle formulas. Okay, so these double angle formulas are going to be useful to us. Like I said, the ones that these are the ones that I have memorized, and I would suggest you do the same. These first two. You don't really need to memorize any of the others, but those two. And they kind of go with our sine, cosine personalities that we learned last time. Okay, so let's look at half angle formulas. So what does it mean to be a half angle formula? What does that mean? So that means that alpha is the angle. Now that's a Greek letter alpha. If you don't really like writing alpha, you can just write A if you want to. I mean, it's just the English version of the Greek letter. It's okay. And so what does it mean to be a half angle formula? It means that you've taken the angle and you've multiplied it by a half. So it's 1/2 times the angle. So we multiply. So instead of a full angle or a double angle, it's a half angle because we're taking the angle and we're multiplying it by a half. Now, here with these formulas, I'm just saying, look who took over these formulas. I mean, are we surprised? Cosine is in every single formula. Cosine is like taken all over the half angle formulas. So sine is, and they're all square roots and they're all plus or minuses. Okay, they're all plus or minuses. They're all square roots. It's 1 minus cosine over 2, 1 plus cosine over 2, and 1 minus cosine over 1 plus cosine. Now these formulas actually are not critical to memorize, so we will deal with these a different way. So let's talk about where the plus and minus come in. So the significance of the plus minus is that basically the plus and the minus are determined by the quadrant of the angle. So we're going to, when we do those problems, we're going to have to investigate which quadrant the half angle is in. We need to know which quadrant the half angle is in. Okay, so that's what's going to help us with whether it's plus or minus. And when I show you how to do it, you might be like, I'm just going to guess. I don't really want to go through that. I just want to say, this feels like a plus. I'm using a plus. This feels like a minus. I mean, I'm not advocating that you do that. I'm just saying it takes several steps to figure out which quadrant it's in. And the only reason we do that is to figure out whether we use the positive or negative version of the formula. That's it. Okay. How are we doing? We ready to move to the examples? Yes, we good? Okay. All right, so let's go to our examples. So our first example gives us sine of x is 7/9. Okay, so I want you to notice something here. A couple things. First of all, that's a single angle. And these are all double angles. So we need to keep that in mind. I am going to draw a triangle for the single angle because 7/9 is not a unit circle value, right? We can't really do anything with that. So that means we need to draw a triangle, right? That terminates in quadrant 2. So let's draw our quadrant 2 triangle. So notice that this is x. This is a single angle triangle. This is not a double angle triangle, so we're not going to be able to read off double angles off of a single angle triangle. That's going to force us to use the formulas that we just found, that we just looked at. Okay, so just talking through why we're doing what we're doing. So let's go ahead and fill out the triangle. So sine is opposite over hypotenuse. So to get the third side, we've got to do what? Pythagorean. So that's 7 squared plus b squared is 9 squared. So b squared is what? 81 minus 49. So b squared is 32. Let's see, 32 is 16 times 2, right? So b is going to be a plus or minus 4√2, because 16 square root of 16 is 4. Now, for our particular purposes, is b going to be positive or negative? Negative. It's going to be negative because it's x and it's in the second quadrant. So we're going to fill that in. That's going to be a negative 4√2. All right, so these give us single angle ratios, not double angle. So if they want us to find sine of 2x, we have no choice but to use the double angle formula to turn the double angle into single angles. Okay, that's the only way we can answer that question. So sine, remember sine is the nice one. So sine has a 2 and sine shares. So it's sine times cosine. That's so nice, isn't it? And so now we just read those values off of our triangle. So 2 is just 2. Sine off the triangle is 7/9. Cosine off of the triangle, let's see, cosine is adjacent over hypotenuse, so negative 4√2 over 9. Okay. So now we've got all that filled in with numbers. We simply just need to do arithmetic and go ahead and multiply all that together. So let's see, what does that give me? So 2 times 4 is 8, 8 times 7 is what, 56. So negative 56 root 2 over 9 times 9 is 81. And so there's our value for sine of 2x. So this is an example of why you would need to use a double angle formula. Okay? Is everybody okay with that? Yes? Okay. So let's go and do a cosine double angle. So remember it's cosine, so guess who's going to come first? Yep, cosine is. And it's going to be fussy, right? Cosine squared minus sine squared. What kind of a formula is that? Cosine squared minus sine squared. So we already know what cosine is. We wrote it on the first part. That was what, negative 4 root 2 over 9. And we're going to have to square that number. And we already know what sine is. That's what, 7/9. And we have to square that number. So now it's a matter of, arithmetic. Let's see. So negative 4 times negative 4 is 16. Root 2 times root 2 is 2. So 16 times 2 is 32. Then 9 times 9 is 81. Then 7 times 7 is 49. Over 9 times 9 is 81. Now we just need to, thankfully they have the same denominator, so we don't need to go through that fun that we have with those. So 32 minus 49 is negative 17 over 81. And that's our double angle value for cosine. Now for tangent, I actually, since I already have the double angle for sine and the double angle for cosine, I could just make a fraction and be done with it. Now it's a complex fraction. I have to mess the complex fraction, mess with it. But just since we can have some experience using the formula for tangent, I would just like to do that. I just want you to know there's another way. You don't have to do this, right? Because we already found sine 2x and cosine 2x. But I just want to use the formula just for fun. So I know I have a weird idea of fun. 2 tangent x over 1 minus tangent squared x. That's the formula. So let's read that off of our triangle. So let's see, tangent is opposite over adjacent. So 2 times opposite is 7. Adjacent is negative 4 root 2 over 1 minus, and then we already know what tangent is at that on that triangle is 7 over negative 4 root 2 squared. Okay, so we plugged into our formula. All we need to do now is arithmetic. Yay, arithmetic. Okay, I'm not that big of an arithmetic fan, sorry. So 2 goes into 4 2 times, or actually we can just leave it. We'll simplify it as we go. I'll just do 2 times 7 is 14 over negative 4 root 2 over, let's see, 1 minus, let's see, 7 times 7 is 49. And we already squared the negative 4 root 2, didn't we? And we got 32. So if y'all are okay, I'm going to turn that 1. I'm going to find a common denominator. And I'm going to turn this 1 into 32 over 32. Is that all right? I'm just going to switch that to be 32 over 32. So that gives me, so we have 14 over negative 4 root 2 over 32 minus 49 is negative 17. So we need to fix our complex fraction. Remember, keep, change, flip. We keep the numerator. And actually, I would like to reduce 14 over 4. Are y'all okay with me reducing that to 7/2? Just take a 2 out of both of those. I would rather fix it to 7 over negative 2 root 2. So that's the numerator, which I simplified a bit. We keep the numerator, we change division to multiplication, and we flip the denominator. let's see, 2 goes into 32, doesn't it? Goes into 32, what, 16 times? Is that right, or have I lost my mind? Right, that's right. So now, of course, I need to do, what is 16 times 7? Oops. 42, 4, 7, 8, 9, 10, 11. So 112. So I've got, and negative times negative is positive. So I've got 112 over 17 root 2. So this is my answer if I don't rationalize. Sometimes the computer program makes you rationalize and sometimes it doesn't, right? So if it doesn't make you rationalize, you put that. We know how to rationalize though, right? We multiply by root 2 over root 2. If you rationalize, the answer would be 56 root 2 over 17. That would be, you could do one or the other. One is rationalized and one is not. Okay. So how are we with our double angles? Everybody okay? Yes? Okay. So now let's look and see how we might see those in a proof. So let's do a proof. I would rather work on the left side than the right because I'm not sure how I'm going to turn 1 plus sine 2x into something squared. That seems kind of hard. So I would rather unsquare that side. I'd rather work on that side. So I'm going to work on the left side and I'm going to just FOIL that out. Okay, so I'm going to do sine plus cosine times sine plus cosine equals right-hand side. And I'm just going to say expand. And this step you can actually skip, you know, if you wanted to just kind of do that out to the side. I'm going to FOIL it out. I'm going to multiply it all out. So sine times sine is sine squared. Sine times cosine is sine times cosine. Cosine times sine is sine times cosine. And cosine times cosine is cosine squared. And all we did is multiply. I can't spell multiply. M-U-L-T, multiply. Okay. Now this is our goal, right? We're going here. We want to get to 1 plus 2 sine 2 theta, or 2x. And I don't see any squareds over there, so it kind of brings my eyes to these two squareds right here, because I don't see any squareds on the right side. Is there anything that we can think of that involves sine squared and cosine squared? Pythagorean identity, right? Pythagorean. So sine squared plus cosine squared is what? It's 1. So I'm going to turn that to 1 plus sine x cosine x plus sine x cosine x equals right-hand side, and we did Pythag. Okay? All right, keeping the goal in mind, I've got a 1. Yay, I needed a 1. Do we see anything we can do there on that left-hand side? Anything like jump out at you? Combine like terms. Combine like terms jumps out. So let's do that. So I have 1 sine cosine plus 1 sine cosine would be 2 sine cosines. Okay, so we just added. You can say add, you can say combine like terms if you want to. We did those things. 2 sine cosine, isn't that something that we just talked about? Didn't we just look at 2 sine cosine? What was that supposed to be? 2 sine cosine. If I go the other way, that turns into, isn't that the double angle for sine? 2 sine cosine. So if I go backwards, I can turn 2 sine cosine into sine 2x. And that's exactly where we need to be. And we just use the double angle. Okay. We doing okay? And there is a proof that's using double angle. All right, so there's only one thing we haven't looked at yet, and that's the half angles. So let's go to our half angles. Let's do a couple of examples on half angles. Now, what I want to remind you, so let me flip back a little bit to the lesson we did last time. You remember when we were doing the addition subtraction properties and we had to figure out, remember back here, we kind of had to figure out what would make 15? Remember that? How could I make 15 adding or subtracting? Remember that? That's the same thing we're going to do with the half angles. Well, on this new one, we're going to have to ask ourselves, what do I need to do to this to make it a half angle? How could I make 15 a half angle? So 15 degrees is the same thing as what? Divided by 2. Yep, very good. 30 degrees divided by 2. That's the same thing. Okay, so this one is fairly easy to determine which quadrant we're in for the half angle. So this is the half angle right here. 30 degrees over 2 is the half angle. And which quadrant is this half angle in? Where is 30 degrees over 2 located? Quadrant 1. So this is an easy one to figure out which quadrant to go to. So we're going to use the positive version. Why? Because cosine is positive in quadrant 1. This is the half angle formula we're using. We're using the cosine half angle. And I'm going to write that formula out. So that was cosine of alpha over 2 equals plus or minus the square root of 1 plus cosine of alpha over 2. So because we're in quadrant 1 and because cosine is positive in quadrant 1, we're using the positive version. So I'm going to use the plus, not the minus. So cosine of 30 degrees over 2 is going to be equal to the positive square root of 1 plus, now cosine of alpha. Alpha is this part up here. It's this part. That part's alpha. So this part is alpha. Okay, so it wants us to do cosine of that number. Now, that's the answer. We've got some arithmetic to do. It's kind of a bit of a mess. Cosine of 30 degrees is a unit circle angle. So let's pull out our unit circle information. So 30 degrees, we know, is right here, right? It's a 30, 60, 90. It's a cosine, so it maps to x. So it's bigger, right? It's flatter along x. So which of those numbers maps to x that's bigger? Root 3 over 2. Very nice, ladies. I'm hoping the more we use the unit circle, the more comfortable you get with it. So I'm replacing cosine 30 degrees with root 3 over 2. Now I've got a complex fraction to fix. So there are several ways to do that. But I tell you the way that will work every time is if you simply add the stuff together in the numerator, add the stuff together in the denominator, keep, change, flip. That's what you do. So I'm going to add the stuff in the numerator together. I'm going to change this 1 to a 2 over 2. So I have a common denominator. So that gives me 2 plus root 3 over, root 3 over 2, all over 2, and I'm making that a fraction. I'm making it over 1. Okay, so we're going to do our super fun keep, change, flip. So I keep the numerator like it is. I change division to multiplication. I flip the denominator upside down, and I get this. 2 plus root 3 over 4. Now I will tell you that the computer program that our book uses would not be happy with us putting it in like this. what they would want us to do is they would want us to split the radical into the numerator and the denominator. That's what they would want us to do. And we know what the square root of 4 is, right? The square root of 4 is 2. So this would be our final answer. This is what they would want us to put in as our answer. Okay, how are we on our very first half angle formula? Okay? Yes? Okay. All right. The second one is a little bit more complicated because, I mean, this I can see is 15 degrees, 30 over 15, that's quadrant 1. The second one is a little bit harder because I don't have a specific angle. I'm given a general information. So the first thing that I would like to do is write down the sine half angle formula so we know what we need. What do we need? Oops. If I want to be sine of x over 2, what does my formula look like? Looks like plus or minus square root of 1 minus cosine x over 2. That's what it looks like. So I do need cosine x, and you know, I've already got cosine x, so I don't really need to do a triangle because I have the one value that I need in my formula. That's going to go right here. So I got that. Okay, what I don't know is if I'm going to use the positive or negative one. So we have to focus on what we're doing. This is sine. Okay, this is sine. And I need to know where sine is positive and negative. If we look at the way this is written right here, if we look at the way it's written, this is for a single angle. For the single angle, I'm between pi and 3 pi over 2, which makes me in quadrant 3. If I was going by the single angle, what is sine, what value is sine positive or negative in quadrant 3? It's negative. So if I was going by the single angle, I would be using the negative version, but I'm not. I have to go by the half angle. So what that means is I have to take this and I have to turn it into half angle. So I have to divide, I have to multiply, I'm going to multiply everything by a half. So I get pi over 2 is less than x over 2 is less than 3 pi over 2 times 2 is 4. This is the half angle that I need to deal with right here. Okay, I don't want to know about the single angle. I don't even need to know the single angle quadrant. I need to know the half angle quadrant. So let's investigate that. So from pi over 2, which would be here, to 3 pi over 4, which would be here, which quadrant are we in? We're in quadrant 2. And what is sine? So we need to be in quadrant 2. What is the value, positive or negative, of sine in quadrant 2? Positive. So we have to use the, see, all of this, all of that crazy writing over there is to figure out whether we're using the positive or negative version of the formula. That's all. So that's why I was saying when I started, I mean, some students might like, yeah, I'm just going to guess. I don't recommend you guessing, but yes, that's what we were doing all that for. So we're going to use the positive version. So the positive version, so 1 minus, so the positive radical, cosine we know is negative 3/5 because they gave it to us already. And so now it's just a matter of, now is arithmetic. So let's see, I'm going to turn this one to 5 over 5. So I have 5 over 5 plus 3 over 5. That gives me what, 8 over 5 over 2 over 1. I'm going to do my keep, change, flip. keep the numerator, change division to multiplication, flip the denominator. That turns out to be 8/10, which is what, 4/5. Again, I don't think they're going to let us leave it like that under the big radical 4/5, so I'm going to have to split it and do the square root of 4 over the square root of 5, which is 2 over root 5. Now, if it lets you do unrationalized things, you would be done. You would say 2 over root 5. If it wants you to rationalize, we know how to do that, right? We just multiply by root 5 over root 5. So the rationalized answer would be 2 root 5 over 5, depending on, and I know it's kind of funny, sometimes it wants you to rationalize and sometimes it doesn't care. All right, how are we doing?
Would you make this